Hello and good evening everyone. I welcome you all to India's largest e-learning platform, Unacademy, and I welcome you all to our channel, GATE Conqueror. We are into EM Wave Propagation. Topic: Wave Polarization. We are into wave polarization. Along with that, we'll also discuss reflection and refraction of plane waves. We'll also discuss about reflection and refraction of plane waves. Before we start the class, let me introduce myself. I am Chaitanya Reddy, having 15 plus years of experience in teaching, guiding and mentoring GATE and ESE aspirants. I work as motivation speaker, pan-India from the past 12 years, expert in field theory and communications. This is our official channel, GATE Conqueror, and this is the official link for the Telegram channel. You can join us on Telegram using this link, and the advantage of joining us on Telegram is you get the access of all the faculties, including the legendary K.N. Rao sir. Good morning, Bhaskar. Today or tomorrow we'll finish off EM Wave Propagation here. Immediately I'll start transmission lines from day after tomorrow, okay? Bhaskar. Unacademy offers two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access. Unlike other platforms, you can join any platform you want. You can join any of the courses that you want within the time span. There is no limitation that you should be only into this particular batch and all. And every week we start 8 or 9 new batches. You refer the playlists that are there on our channel carefully. Most of the EMFT is covered. Only thing is we need to start transmission lines and waveguides that I'll start in a couple of days. For rank improvement batches, and generally they charge separately for rank improvement batches, but rank improvement batches are also included within the Plus at Unacademy, and also crash courses you can avail within the Plus subscription. So that's the advantage that you have by taking a Plus subscription. If you take an Iconic subscription, you'll get all these features of Plus subscription. Along with that, you get a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts within 24 hours, preparatory study material, specialized practice sets, personalized test analysis. They'll try to make up your SWOT analysis, and we try to focus. The personal coach will focus on your weaker sections or weaker parts of the subject, and we try to improvise on it. Study booster sessions or workshops and customized study planner. We all believe that a study planner that is suitable for one fellow, one student may not be suitable for other. We need a customized study planner that will be designed by your personal coach. This is an Iconic subscription. Whether you go for a Plus subscription or Iconic subscription, I recommend you to go for a no cost EMI. The total cost will be divided by number of months without any extra cost, and also you can use our team code KNR10 which gives extra 10% off and complete team support. This is our team code KNR10, which can be applied for both Plus and Iconic subscribe. For both Plus and Iconic subscriptions, you can apply our code. With Iconic subscription, you get 1:1 live mentoring, increasing your chance of getting a top rank. On 10th of April, this Sunday at 11 a.m., we have combat for GATE and ESE. 20 questions will be given, 60 minutes will be given. Separate paper will be given for mechanical, civil, electrical, EC and CSIT. And try to compete with the best through this paper, which is designed by India's topmost educators, so that you understand where you actually stand and also compete with the real and competent aspirants, your friends, so that you understand where you actually stand in the real competition. And if you score a rank between 1 to 3, we are ready to give away 100% scholarship or free subscription. And for 4 to 10, we give away 75% discount or 75% scholarship. 11 to 50, we give away 50% scholarship. And 51 to 100, we give away 25% scholarship. And the good thing is there is no enrollment fees. You can enroll using our team code KNR10. That's a good thing. We don't charge anything for this. And the good news is for GATE and ESE aspirants, we got the study material now available, curated by India's topmost educators, where we have comprehensive syllabus coverage and we have solved examples to build problem solving skills. We have chapter wise practice questions and it can be accessible anywhere and anytime. And the good thing is it is available for Plus as well as Iconic learners. That's a good thing. And you can subscribe using our team code KNR10. Is that clear? These are GATE 2022 top 10 rankers. You can see in top 10 rankers, we have 3 All India 1 ranks. We have 3 All India 1 ranks here, which speaks volumes about the quality of education that we provide at Unacademy. So join us to crack the exam, dear. Join us to crack the exam. These are the results that shows you that we can be on the top of this competition easily by joining us. Once you join us, that means you have been associated with the India's best faculty. The good news is the price rise is extended up to April 7th, dear. So try to utilize this and try to beat the 10% hike in the price. And you can use our code KNR10, the team code, to get extra 10% off. Get in touch with our counselor. If you have any doubt in preparation journey, subscriptions and latest offers, you can dial this number and get in touch with our counselor. Our counselor will be more than happy to help you out or guide you in this particular journey. This Unacademy Ask a Doubt feature, very unique feature, available both on app and website, where students can ask unlimited number of doubts. You can ask 3 doubts at a time. You can ask 3 doubts at a time. And one second. You can also get the solution in your preferred language. It is also very easy to ask your doubt. Just click, crop and submit. Just click, crop and submit. These are special class features which includes interactive live classes, polls for the learners, raise hand option. You never miss a class when the notification is on. You can download the lecture notes then and there. You can access anytime and anywhere. These are the special class features, dear. The upcoming one will be at 11 a.m. Introducing community. You never miss any update from your favorite educator. Get session notes and practice material. Share your feedback directly via polls. These are the new batches, dear. Every week we start 7 to 8 new batches. These are the batches starting on March 30. Resilience, batch for GATE 2023 for electrical, explained bilingual. Resilience batch for GATE 2023 for EC, explained bilingual, started on March 30. Evolve batch for GATE 2023 for electrical, explained bilingual will start on April 6, that is tomorrow. Evolve GATE 2023 for electrical, explained bilingual will start April 6th. Ascend GATE 2024 for electrical, explained bilingual will also start on April 6th. Ascend GATE 2024 for electrical, explained bilingual will start April 6th. All this you can, for all these batches you can use the code KNR10 to get extra 10% off. We are into EMFT and we have the concept of EM wave propagation. In couple of days, 4 new faculties, 4 excellent faculties, 4 new faculties are going to join us on our channel. They will be serving you on YouTube. So try to get up yourself. Be prepared, all the GATE Conqueror followers. Be prepared for a comprehensive coverage of syllabus for GATE 2023 and ESE 2023. And I take the responsibility for completion of EMFT. EMFT contains 5 modules here. And I'll cover it for GATE 2023 and also ESE 2023. All the derivations, the most difficult derivations will be simplified and explained on YouTube for you. So EMFT contains 5 modules. Already a lot of data is available on our channel. Module 1. Elements of EMF theory, which is common for both EC and electrical. Already a playlist is created for this with 40 videos and 50 hours of content. 50 hours is very huge content here, because generally for elements of EMF theory, maximum content available on any YouTube channel is around 8 to 10 hours. Against that, we have some 5-fold or 6-fold more content on our channel. Very easily, with this much of content, both EC and electrical people can prepare for GATE and ESE. And I can say this is the best content available for you on any YouTube channel. Just go through this playlist. For triple E people, it is complete syllabus dear. One second. Yeah. Module 2. This is the current module. EM Wave Propagation. You got a playlist. 14 videos, and 28 hours of content. Again, EM wave propagation, maximum 8 to 10 hours of content will be available. We got 14 videos and 28 hours of content here. In EM wave propagation. Module 3 is transmission lines. Again, this can be used for both GATE and ESE. Transmission lines we need to start. We'll start very soon. Module 4 waveguides, which includes rectangular waveguides and circular waveguides. This also will start soon. Module 5 optical fiber communication and antennas. For antennas, optical fiber communication, I'll take separate series here. For antennas, Mahamarathon series, (18 videos), and 38 hours of content. Some more previous year questions are left out here, that I'll finish it off, and this I'll take a separate series. Already module 1 it is done completely, 50 hours of content. Module 2 90% is done. (28 hours of content). Module 5, you got 38 hours of content. Already 116 hours of content is available. I'll be planning 104 hours of more content, making it 220 hours for EMFT. That is what I'm trying to plan. In couple of sessions, we'll complete EM wave propagation. This module will also be completed in couple of sessions. This is already done. Here, if I take 2 more classes, antennas will be done. And 6 to 8 hours of sessions, OFC will be done. First, I'll try to finish off these small residual parts so that the content is fully available for module 1, module 2 and module 5. Then we can happily start 3 and 4 parallelly. That's the idea. Whatever content is there, if it is available fully, then we can go for module 3 and module 4. Is that clear, or any other pattern you want? Any other way of completion you want, you can let me know. That's my basic idea. Clear? Module 1, elements of EMF theory, common for EC and electrical. Electrical, it is complete syllabus. For EC, it is 1 module among 5. As I told you, we have the playlist ready. with 40 videos and 50 hours of content. That is in module 1. Module 1 we are divided into 3 parts. Basics, static field theory, and time varying field theory. Under basics, we have 2 parts. Elements of vector calculus, and coordinate system. So under basics, first one is elements of vector calculus. In elements of vector calculus, what's the doubt here? Let me know. In elements of vector calculus, we discuss concepts like scalar. What is scalar, dear? A scalar is a quantity which is having only magnitude, no direction. It's called a scalar quantity. Example, distance and time, voltage and current. Most of the people feel that current is vector, but it is not. Current is a scalar. Why it is scalar also I explained in the playlist very clearly. Please go through it. Then the vectors are like acceleration, velocity, displacement, force, torque, current densities, dipole moments. All these are vectors which contain both magnitude and direction. That is unit vector. Unit vector is one which gives you the direction of the vector at any point. Then we had seen how to add vectors. Under addition of vectors, I made a video on why current is scalar. Please go through it. Please go through it. In addition of vectors, it's in parallelogram law, head to tail rule. Head to tail rule is also called as triangular law. Some very interesting concept we have done on this addition of vectors. Please go through it, okay? What's your doubt you can ask? That is on addition of vectors. Then we had gone through basic laws of vectors. What are basic laws of vectors? What are basic laws of vectors? Commutative law, associative law, and distributive law. Addition and multiplication. Especially in distributive law of multiplication, I explained a very important point. Please go to the playlist for understanding that important point. Then we have seen multiplication of vectors. Then we have seen multiplication of vectors. Under multiplication of vectors, you went for scalar product, dot product or scalar product, vector product or cross product. We have seen this two things, dot product and cross product, under multiplication of vectors. And also we have seen what are the basic laws that are obeyed by dot product and cross product. Very interesting concept. Don't miss this. One more very strong basic concept about multiplication of vectors we have dealt. And one more strong concept, del operator. Del operator is nothing but a vector differential operator or spatial derivative operator. We discussed about del operator and its properties. Very interesting, very strong concept this is. Please go through it. And also we went for vector identities. What are vector identities? These are some of the rules which must be obeyed by vectors and scalars. Two most famous vector identities. Divergence of curl of any vector is 0. Divergence means del dot. Divergence of curl of any vector is 0. Curl of gradient of any scalar is 0. These two are the vector identities. And this part was very, very interesting. Please go through the basics. Part A, elements of vector calculus. Part B, we had seen coordinate system. Let's see types of coordinate system first. Types of coordinate system. Types of coordinate system we have seen Cartesian coordinate system, also called as rectangular coordinate system. Second is cylindrical coordinate system. are also called as circular coordinate system. Next is spherical coordinate system. And see what are the coordinates, what are their range, how are they defined and all. In Cartesian coordinates XYZ, cylindrical rho phi z, spherical r theta phi. For detailed explanation about the definitions, range and all, you can please go to the playlist. For module 1, you will get the detailed solutions. One, the types of coordinate system, their range has been defined. We went through point transformation. This speaks about how to convert a point from one coordinate system to another coordinate system. Very important concept. Please go through it. Then we had seen unit vector relations. What are unit vector? Along in Cartesian coordinate, unit vectors are Ax, Ay, Az. In cylindrical, it is A rho, A phi, Az. In spherical, it is AR, A theta, A phi. Now, how these are interrelated is this topic, unit vector relations. Yet again a very important topic. All these basic topics are very, very important here. Then we went through defining differential length, differential surface and differential volume in all three coordinate systems. Then we define divergence, curl, gradient and Laplacian in all three coordinate systems. Yet again, so very, very important. All basics are very important here. The uniqueness of our course is like we try to stress more on basics so that later on things will become easy. Almost in that playlist, we spent around 15 hours only on basics here. I can surely tell you that you cannot find this kind of a content on any YouTube channel. Exclusively we are dealing with so many hours of content only on basics. Clear? Then part 2. Static field theory. Static field theory. We have electrostatics and magnetostatics. Under electrostatics, most important topics we have discussed is Coulomb's law. Coulomb's law is the most generalized law that governs electrostatics. We discussed on Coulomb's law and its applications. Applications is over line charge, surface charge and volume charge. And also under special case, we'll also discuss the very important method of images under this. Then under electrostatics we have covered Gauss law. Gauss law is a special law that governs electrostatics, and also we have seen its applications for point charge, line charge, surface charge and volume charge. And Gauss law is a special law which can be applied only when we define Gaussian surface. And what is the Gaussian surface? A Gaussian surface is one which is symmetric with respect to charge distribution. Gauss law can be applied only when you define Gaussian surface. A Gaussian surface is one which is symmetric with respect to charge distribution. For point charges, the Gaussian surface is a sphere. Example. That means if you are standing on this surface, your friend is standing on this surface again, you both are at equidistant from this charge. So this surface is said to be Gaussian surface, which is symmetric with respect to charge distribution. That is the meaning. So Gauss law can be applied only when Gaussian surfaces are defined, but it is a more simplified form. And we have also seen exclusively their applications over point charge, line charge, surface charge and volume charge. And we have done numerous number of practice questions and previous year questions both on Coulomb's law and Gauss law exclusively. Near about, I remember, 100 questions we had solved only on Coulomb's law and Gauss law. Such a detailed explanation is given in this playlist. Along with that, we have seen topics like electric potential, also called as EMF, electromotive force. It's in topic called relation between E and V. These are the main concepts that we have discussed under electrostatics. Under magnetostatics, discuss the generalized law that governs magnetostatics, Biot-Savart law. And we've seen the application over line current. Again, very important law, Biot-Savart law, generalized law that governs magnetostatics. See, Ampere's law. Ampere's law. Again, it is a special law that governs magnetostatics, applicable only on Amperian paths. An Amperian path is one which is symmetric with respect to current distribution. If you take a straight current carrying conductor carrying a current I, then a loop of radius r where the current carrying conductor is moving through the center, is the Amperian path. And Ampere's law, this is a special law that governs magnetostatics. Just like we have defined electric potential or electromotive force here, we derived scalar magnetic potential, also called as MMF. Remember, EMF is voltage, MMF is current. And unlike electrostatics, we have two potentials here, scalar magnetic potential and vector magnetic potential. we need to define vector magnetic potential because scalar magnetic potential is defined only for free space or in perfect dielectrics where sigma is 0. This concept is called failure of MMF. Some beautiful explanation is also given on this concept of failure of MMF. And the common topics that we have discussed, which are common for both electrostatics and magnetostatics, are work done and energy density. We define work done and energy density both electrostatics and magnetostatics. We define Poisson's and Laplace equations, especially problems, numericals. Some beautiful numericals were done on Poisson's and Laplace equations for both electrostatics and magnetostatics. Derived boundary conditions, dielectric boundary condition defined for both electrostatic fields and magnetostatic fields. And in electrostatics we have defined capacitors and types and some beautiful problems on this. And here we have defined inductors and types and some beautiful problems here also. So overall, wonderful concepts explained in static field theory. And as a summary of this, we boil down these things into one point. That is, we are derived, discussing all these important points exclusively, we are derived finally Maxwell equations. For static fields. Equation number integral form, differential form, integral form, differential form, and source. Equation number 1. Closed surface integral of d dot ds is equal to volume integral of rho v dv. Differential form del dot d is equal to rho v. And what is source dia? Source Gauss law for electrostatic fields. Second equation, closed loop integral of E dot dl is 0. Differential form del cross E is 0. E is irrotational field. E is conservative field. Source conservative property of electrostatic field. Electrostatic field is conservative, it is irrotational. They move in straight lines. Third, closed loop integral of h dot dl is equal to surface integral of j dot ds. Del cross h is equal to j. Ampere's law. Fourth, closed surface integral of B dot ds is 0. Del dot B is 0. B is divergence-less field or solenoidal field. Source, non-existence of magnetic monopole. A magnetic monopole does not exist. They always exist in pairs. It's also called as Gauss law for magnetic fields. Any doubt here? Then, in time varying fields, also we have derived Maxwell equations. In time varying fields, the first and fourth equations will remain same, dot products, and cross products are going to vary. This thing we vary with using Faraday's law. And equation 3 we vary with concept called Maxwell contribution, or also called as inconsistency of Ampere's law. The third section that we have discussed is time varying fields. In time varying fields, two important concepts were discussed and modified the Maxwell equations. The first one, Faraday's law. Second, inconsistency of Ampere's law, are also called as Maxwell contribution. For detailed derivation and solution of this, please go through the playlist. After these two changes, the Maxwell equations, time varying fields are given by equation 1, no change. Closed surface integral of d dot ds is volume integral of rho v dv. Del dot d is rho v. Gauss law for electrostatic fields. Second, this from Faraday's law. Closed loop integral of E dot dl is surface integral of minus dou b by dou t dot ds. Del cross E is equal to minus dou b by dou t. Faraday's law. Third one, closed loop integral of h dot dl is surface integral of j plus jd dot ds. Differential form del cross h is equal to j plus jd. J is conduction current density given by sigma E. And jd is displacement current density given by dou d by dou t. And this is The concept of Maxwell contribution, also called as inconsistency of Ampere's law. Fourth equation, no change, closed surface integral of B dot ds is equal to 0. Implies del dot B is 0. B field is divergence-less field or solenoidal field. This from the property of non-existence of magnetic monopole. A magnetic monopole does not exist. They always exist in pairs like north and south pole. It is also called as Gauss law for magnetic fields. Is that clear? Besides Maxwell equations, in module 1 the most important after Maxwell equations are boundary conditions. Please stress on these boundary conditions, because boundary conditions are defined for dielectric boundary conditions, and dielectric conductor boundary conditions. Dielectric conductor boundary conditions. Dielectric boundary conditions. The condition that we got. What's the first boundary condition? Anyone? First boundary condition that we got, ET1 is equal to ET2. Tangential component of electric field is continuous across the boundary of discontinuity. It is unconditionally continuous. Second one, dN1 is equal to dN2 if and only if rho s is 0. Normal component of electric flux density is continuous across the boundary of discontinuity if and only if rho s is 0, where rho s is the surface charge density that is placed deliberately on the surface of the boundary. It is conditionally continuous. Third one, HT2 minus HT1 vector form is equal to K cross AN. Scalar form, HT2 minus HT1 is equal to K. Boundary condition, HT1 is equal to HT2 if and only if K is 0. Tangential component of magnetic field intensity is continuous across the boundary of discontinuity if and only if the surface current that is deliberately placed on the surface or the boundary surface is equal to 0. It is conditionally continuous. Last one, Bn1 is equal to Bn2. Normal component of magnetic flux density is continuous across the boundary of discontinuity. It is unconditionally continuous. Very, very important boundary conditions, and boundary conditions are useful to predict the field on the other side of the region when the field on your side of the region is known to you. Dielectric conductor or dielectric perfect conductor boundary conditions. As you know, no field component can exist in perfect conductor. It will become 0 if you try to simplify these equations. For dielectric conductor boundary condition, you get one village becoming 0. If for E tan is equal to 0, implies the tangential component of electric field on the surface of a perfect conductor is always 0. Very important conclusions. Second, here you got Here you got dn2 minus dn1 is equal to rho s. Then I substituted rho s 0, I got this. So now you substitute one component 0, then you get d normal is equal to rho s. Normal component of electric flux density is equal to surface charge density. That's the reason why d and rho s has same units, Coulomb per meter square. Similarly, here if you substitute one quantity as 0, H tan is equal to K cross An. That's the reason why H and K are also having same unit. What is the unit of H? HDA? Magnetic field intensity, ampere per meter. Surface current, ampere per meter. Ampere per meter. Got it? And here, B normal is equal to 0. This very rarely someone will explain about dielectric conductor boundary conditions like this. Very, very important boundary conditions derived exclusively for you people. Please go to the playlist. Module 1 playlist, which will cover all the syllabi for electrical people here. I am insisting again and again because this playlist is enough for you to prepare for GATE and ESE for electricals completely for EMFT subject. Got it? In module 2, current module, module 2, EM wave propagation. It describes about how EM waves are propagating in different mediums. The major topics are EM wave propagation in free space. Free space means sigma 0, epsilon r1, mu r is 1. Second, and in EM wave propagation in free space, we have derived expressions for alpha, beta, velocity and eta. Alpha you got it as 0, beta you got it as omega into under root mu naught epsilon naught, velocity you got it as c, eta you got it as 120 pi. We derived them, please go through. Next is EM wave propagation. In materials with finite conductivity, sigma naught equal to 0. Epsilon r greater than 1, mu r greater than 1. Here we have derived generalized expressions for alpha and beta, generalized expressions for alpha and beta. We defined loss tangent, also called as dissipation factor, given by tan phi, sigma by omega epsilon, where phi is 2 times of theta n. where theta n is angle of intrinsic impedance. Angle of intrinsic impedance. We have discussed on this. We derived alpha, beta. Along with alpha and beta, we have derived terms like velocity and eta. This we have done in EM wave propagation materials. Then we went for EM wave propagation in good conductors. Good conductor is the case where sigma is far greater than omega epsilon. Sigma by omega epsilon is far greater than 1. Sigma by omega epsilon is greater than 100. In good conductors, we have derived quantities like alpha, beta, and we got alpha is beta, of course, velocity, penetration depth, delta, skin resistance, penetration depth or skin depth, and we're seeing surface resistance or skin resistance Rs and eta. And we're seeing EM wave propagation in good dielectrics. Sigma far less than omega epsilon. Sigma by omega epsilon far less than 1. Sigma by omega epsilon less than 1 by 100. Okay? And here we have derived alpha, beta, velocity and eta. Fifth one. EM wave propagation in perfect dielectrics. Sigma is 0, epsilon are greater than 1 and mu r is greater than 1. Derived expressions for alpha, beta, velocity and eta. All these derivations are done in the playlist. There are some beautiful concepts are been explained. Just I am trying to give the synopsis here, which completes EM wave propagation in different medium. And also some beautiful comparison chart is given. For now, I cannot explain everything again. You can just go to the playlist, the current playlist of EM wave propagation. Just I'll give you the comparison chart for you. And in this comparison chart, I'll explain the terms, different terms propagating through different mediums. Let me start with free space. Then perfect dielectric. Perfect dielectric. Then good dielectric. Good conductor. And perfect conductor. Let us start with sigma dear. Conductivity. Please tell me. Conductivity. Start with conductivity and tell me dear. Start with conductivity and tell me. In free space, how much is conductivity? Free space cannot conduct, okay? Conductivity is 0. Perfect dielectric, like wood. Epsilon r greater than 1, mu r greater than 1, epsilon r is equal to 1, mu r is equal to 1. But perfect dielectric is also insulator, it cannot conduct like rubber or wood. Sigma 0. Good dielectric like glass, it will have little conductivity, small conductivity. Good conductor, large conductivity. Perfect conductor, infinity. The journey of conductivity through different mediums now. The first factor. Second, let us do analysis for alpha. Now tell me dear, how much is alpha? Very easy. Basing on the conductivity, tell me the alpha value. How much is alpha value? Alpha, no conductivity, alpha 0 for free space, no attenuation. Perfect dielectric, no attenuation, 0. Good dielectric, alpha, yes, there will be some attenuation but very small. Depends on sigma, sigma by 2 into under root of mu by epsilon. Good conductor alpha under root of omega mu sigma by 2. Here sigma is infinity, alpha is infinity. Perfect conductor attenuation is infinity. Therefore, it cannot pertain. It cannot pertain there. Because in perfect conductor, it will undergo infinite attenuation. That's why wave cannot exist in perfect conductors. This is the least value. This is the highest value. Least, highest. That's beta value. Beta is omega into under root of mu naught epsilon naught. If you go for perfect dielectric, beta is omega into under root mu epsilon. But you know mu is mu naught mu r. Epsilon is epsilon naught epsilon r, mu r is greater than 1, epsilon r is greater than 1, very clearly beta value is increasing. So this is the least value here. Slowly beta is increasing. Now the beta here. Omega into under root mu epsilon 1 plus sigma square by 8 omega square epsilon square. That is beta is omega into under root mu epsilon plus omega into under root mu epsilon to sigma square by 8 omega square epsilon square. Still increasing. Slowly the value is increasing here. Okay. Then the beta value here. Under root of omega mu sigma by 2. Sigma is a very large value. Therefore beta is still increasing. Perfect conductor, sigma is infinity, beta is infinity, highest. Journey of beta in different medium. Next, velocity 1 by under root of mu naught epsilon naught, which is velocity of light. Here velocity 1 by under root mu epsilon, which is c by under root of mu r epsilon r. Mu r is greater than 1, epsilon r is greater than 1. Velocity is decreasing. Is v is c and here v is less than c. So here it is having highest value, highest velocity. That is velocity of light. Then it is decreasing. Next case still decreases 1 by under root mu epsilon 1 minus sigma square by 8 omega square epsilon square. Still decreasing. Velocity under root of 2 omega by mu sigma. Sigma is very large value. Velocity is still decreasing. Your velocity is 0, least value. In perfect conductor, the waves will move with 0 velocity. That's why waves cannot exist in perfect conductor. Any doubts? Is that clear? Next, eta. Eta is under root of mu naught by epsilon naught. 120 pi, 377 ohm. Here eta 120 pi into under root of mu r by epsilon r. Mu r value practically is approximately equal to 1. Epsilon r greater than 1. Eta decreasing. And in both these cases, eta is real value because sigma is 0. Whenever sigma will come into picture, eta will become imaginary. Eta under root of mu by epsilon 1 plus j times of sigma by 2 omega epsilon. Eta is under root of mu by epsilon into 1 plus j times of sigma by 2 omega epsilon. It is really complex in nature here. Here eta under root of omega mu by 2 sigma plus j times of under root of omega mu by 2 sigma. Both these cases, it is complex in nature because when sigma is introduced, it introduces a reactance component, making the intrinsic impedance a complex value, adding reactance to it. Sigma is infinity, eta is 0. Wave does not exist, so no question of impedance there. This table is very, very important here. Clear? It's EM wave propagation in different medium. These are the 5 topics and this is analysis. 6th one, is Poynting theorem. This gives you the amount of power associated with the given EM wave. From this you got an instantaneous Poynting vector. Instantaneous Poynting vector. P sinusoidal is equal to E sinusoidal cross S sinusoidal. Analogy. Instantaneous power. W sinusoidal is equal to V sinusoidal into I sinusoidal. Complex Poynting vector 1 by 2 E cross H conjugate. Complex Poynting vector complex power. One by 2 V into I conjugate. From this average or real power. 1 by 2 real part of E cross H conjugate. Average or real Poynting vector. The real power. Average for 1 by 2 real part of V into I conjugate. Imaginary Poynting vector or reactive Poynting vector. 1 by 2 imaginary value of E cross H conjugate. Reactive or imaginary Poynting vector. Imaginary power or reactive power. One by 2 imaginary part of V into I conjugate. These are the Poynting vectors that we got from Poynting theorem, where we have done power analysis. This is also completed very easily, and all the questions have been explained very clearly. Previous year questions have been solved. And wave polarization. In wave polarization, it's in 3 different types of polarization, that is linear polarization, circular polarization and elliptical polarization. In this, the derivation was done, shortcut was explained, previous year questions and practice questions of all these wave polarization concept is explained very clearly. Basically, the wave polarization is decided by the orientation of electric field. Based on the orientation of electric field, wave polarization is of 3 types: linear, circular and elliptical polarization. We had explained all these 3 different types of polarizations. We have done the derivation, we have done the previous year question paper, we have done the practice, all that we have done very clearly. No problem here. The 8th topic and the last topic that is left out in this module is reflection and refraction of plane waves. In reflection and refraction of plane waves, we need to go through normal incidence. In normal incidence case, again we need to find reflection coefficient and transmission coefficient for electric field, and reflection coefficient and transmission coefficient for magnetic field. Then we go for oblique incidence. In oblique incidence, we need to see, or we need to undergo 2 different cases: perpendicular polarization parallel polarization. Perpendicular polarization and parallel polarization. In both the cases, again, for both the cases, we need to derive gamma E, tau E, gamma H and tau H. And under this, we'll discuss very important concept, like critical angle, total internal reflection and Brewster angle. Brewster angle is the angle of incidence for which reflected wave is 0. Total internal reflection is the angle of incidence for which transmitted wave is 0. these two important concepts are to be covered in reflection and refraction of plane waves. This completes module 2. Most probably tomorrow we'll complete this module 2. This small part theory is left out, plus previous year questions, plus practice questions. If you finish this comprehensively, we had finished module 2 also. Only one small topic is left out here. We'll finish it off. This one small topic we'll try to finish it off in the next class. Mostly, hardly it will take couple of sessions to finish it off. This will be taken care. Then in module 5, we have optical fiber communication and antennas. Here, optical fiber communication, I will take a separate series on this. Antennas we had covered, as I told you, we had covered in antennas Mahamarathon series. We had 18 videos and 38 hours of content. Generally 8 to 9 hours of content will be available for antennas. Against that, we have recorded 838 hours of content where we had explained about basics of antennas, current distribution in antennas, radiation mechanism of antennas, for the radiation to happen, it should satisfy the equation L into di by dt is Q into acceleration. Then we have seen radiation through single wire, 2 wire and dipole. That's the radiation mechanism for single wire, 2 wire and dipole. And we are seeing radiation parameters. Let's see, radiation parameters. In the radiation parameters, we had seen gain, direct to gain, power gain, directivity, efficiency, radiation resistance, and so on. We discussed about radiation parameters. Then we have seen antenna arrays. In antenna arrays, we have covered 2-element array, n-element array, and our special arrays. We have covered Hansen and Woodyard array. I can tell you one thing here, in antennas, we have covered everything actually. Hansen and Woodyard array and binomial arrays. We discussed about the advantage and disadvantages of this exclusively. Then we had seen the 7 sister antennas. Which are folded dipole, Yagi-Uda, helical, microstrip array, horn, parabolic reflector and lens antennas. Beside these 7 sister antennas, we had seen resonant and non-resonant antennas. Under resonant, we had seen monopole, dipole, The non-resonant we had seen V antenna, inverted V antenna, rhombic antennas, antenna measurements, we have seen setup required for radiation pattern measurement, we have seen high frequency method and low frequency method of measurement of radiation pattern, two standard methods. We have seen measurement of gain by first method or tree antenna method, and second method or measurement of absolute gain by two standard antennas. We have seen measurement of directivity as it involves double integral. We had used graphical numerical methods, namely orange slice method and conical cut method. Besides this, we have seen wave propagation, we have seen three principal modes of propagation: ground wave propagation, sky wave propagation, and space wave propagation. Under special modes of propagation, we had seen scatter propagation. Under scatter propagation, we have seen troposcatter propagation, ionospheric scatter propagation, and under special mode we had seen duct propagation. Besides these, we had seen structure of atmosphere, which includes structure of troposphere and structure of ionosphere. We derived refractive index of ionosphere, it's in concept like mechanism of radio waves bending by ionosphere, virtual height, critical frequency, maximum usable frequency, least usable frequency, and optimum working frequency. But in all this, besides this, we had seen ionospheric abnormalities, and we had discussed about 10 important causes for ionospheric abnormalities. We derived range of space wave propagation, which we got 3.57 under root of HT plus under root HR kilometers. HT and HR height of transmitter and height of receiver antennas in meters and range in kilometers. But range is 3.57 under root HT plus under root HR kilometers. We have derived the expression of received electric field strength in space waves. Mod of ER is 88 root P HD HR by lambda D square. We have derived types of fadings and path loss calculation. Because path loss is 32.45 plus 20 log frequency in megahertz to base 10 and 20 log distance in kilometer to base 10. Just go through antennas Mahamarathon series, dear. Very clearly we have discussed all these things in detail in antennas Mahamarathon series. Please go through it, okay? The next class we will see reflection and refraction of plane waves. The next session we will be seeing reflection and refraction of plane waves, dear. Till then, have a good day. Thank you all. And please do not forget to subscribe to the channel if you are new and share among your friends so that this wonderful content is reached to maximum